Hello. Wow. I'm kind of impressed. I was not expecting so many people around, so great. I guess AI is still a training topic these days, so that's cool. Uh, my name is G, aka Guillaume, French, living in the US. We don't really care about everything else. Been tinkering with PHP for like since PHP 3, so 20 years ago, something like this. And more recently, got a lot more into machine learning, AI, running models, tuning them, and stuff like this. So that talk, it's only 30 minutes. I've got a lot to cover, but I'll try to be as clear as I can. We're going to go over how to basically run machine learning and AI models with PHP directly without anything else. So first, we need to talk about Transformers, not the movie, the good ones, the shitty ones. We're not going to talk about that. Just please raise your hand. Have you ever used Transformers? Do you know what this is in AI and stuff like this? Okay, 2%. All right, good. So the good news is I've scheduled a bit of introduction. So as you know, when you need to do some machine learning and AI task, you always have a model that contains a lot of the data that has been trained, and then you run it, you give it some parameters, and you get an output. So those models could do basically anything. Around 2016, 17, we tried to have a large bottleneck on resources. Running those models out of the box was slow. You couldn't do parallel things. It was really bad. So for everything related to language, NLP and stuff, that was not optimized. So a lot of people started working on what we call transformers, and transformers helped a lot on that processing, making it more efficient, faster, being able to parallelize things. And that's where we've seen models like GPT and BERT coming to life. So I'm just going to talk like 5 minutes about that model, at least. Ooh, clicker is not working well. So that may seem a bit complex, but basically transformers can be used inside the model or as libraries. That's what we're going to talk about today. And they've been developed by different companies, different people. The most famous ones, obviously, are Hugging Face with all their Python and Node.js transformers these days. And basically, transformers are a way to encode data and processes and decode them. So instead of feeding raw data to your model to train it, you basically feed an encoded version of it with some pre-treatment. If I've got some experts in the room, please forgive me. I can't go into too many details, so it's kind of superficial. And something really important that a lot of people work on is what we call self-attention. So when you feed some parameters, like a sentence to a model, and I'm sure you've all used ChatGPT and stuff, when you send a sentence, the first step for ChatGPT and the others is to try to understand what you just wrote. If you take a sentence, the AI is going to split everything into what we call tokens. Tokens are usually words, could be smaller than words sometimes, but then it's going to try to figure the relationship between those words. And that's really important because one word can be used in so many different contexts, could mean so different things, especially in French. So it's really important for the model to try to figure out what you are trying to do. So in order to do that, we always use neural networks, and we feed the parameters again and again, try to apply different weights to try to match what you're trying. So for example, let's say you want to finish that sentence. Symfony is a great framework for something. The AI is trying to figure out what you want, and it's going to try to link framework, Symfony, great, is for. We're going to show an example of that just afterwards. So thanks to these transformers, we are now able to do a lot of parallel processing. And that's great because now you can feed a lot of information and run a lot of different instances of your model and just crush through that data and output it. But once again, the most interesting part is the context understanding. Now, if you feed him like a whole PDF document, he's going to scan anything, do the relationship between the different words, try to find what's important, what's not, what are the words that have a lot of meaning, and the others that don't. And thanks to that, we're now able to run those models on machines that have lower resources and at a larger scale. So let me do just a quick demo about the transformers, and then we'll switch to the PHP side. If you want to learn more about this, I can't recommend enough the Harvard is doing an online course called CS50 for programming, which is mostly Python. And they've got the CS50 AI, which is just great if you want to learn more about all this. So let's try to do the completion I was just talking about. So let's put a phrase. And I hope I've got the phrase copy pasted. Yep. And basically what we're going to ask our AI there is to, and I'm sorry that we're at the bottom of the screen, but basically replace the mask there by something. And what I'm running there is just on my local machine. That's a really small model. It's not like Claude or ChatGPT or anything. And basically the thing is going to suggest me, okay, web, software, and new application. Okay, cool. The example is not that important. What's important is just to see how it did it. So what I've done there is that for every iteration that went into the model, I'm mapping out the relationship between the different tokens on that phrase. So for example, you see that Symfony has been split into 4 different tokens. Then we've got basically every words. And we're feeding that into the neural network again and again. I think, I don't know how many iterations I've gone through. 144. And for every iteration, it's going to try to map the relationship between the words and try to understand what is the context, what the user actually wanted to say. So we can see, for example, let me see. It isolated mask right there. We see the white square and then map that to Symfony and the other thing. So because of that, and because of those transformers, we can actually get a lot of better results and more performance. That was basically the take of it. So transformers have been really popular. We've seen a lot of libraries. Hugging Face, once again, developed the Python and Node.js one. And now we can actually see that starting on PHP as well. And that's really interesting because when you're thinking of machine learning and AI, you're not thinking PHP. You're thinking Python, sometimes Node if you want to do web stuff, but never really PHP. And that actually works. So we're going to go through 3 different use cases, but just for starters, that's how you would start tinkering with that. Kirian has a really nice package called Transformers PHP, nothing new, available that's going to implement all those different libraries. It's not a direct port of the Python one, but basically the API is kind of the same. And then those libraries will allow you to actually run different models that you can find online. If you're not familiar with it, go to huggingface.co. They've got, I think, nearly 1 million model available right now. And just because, well, we've discussed that with Fabian a lot, those models are not open source. They're open weight, which is a tiny difference, but basically you don't really know how they work. You just understand and you can see how they relate things together, but you don't know the data they've been pre-trained on and stuff like this. So when you want to start a new project, you just install the library. And then you need to set up some components that are going to be architecture dependent. And that's the bit of the downside. If you are on Mac with an M1, you're going to download RN64 packages or AMD64 on more classic machines. Those transformers need to be precompiled for your platform. So sometimes you could have differences depending on where you're deploying. And then we're downloading 2 basic models. The first one is just capable of actually outputting text and analyzing text. The second one is image classification. The models themselves are not really important there. So we're going to start by doing text classifications. And as we can see in that just code extract, and forgive me if the code is not that great, that's not the important part of it. What we're going to do is actually analyze Amazon.com reviews for a product and try to define if they're positive or negative. That sounds really basic, but that's actually a use case you can run in your own application. Most of you manage websites where you've got user-generated content, right? Comments, reviews, sometimes uploaded pictures and stuff. And for example, that's a good use case for preventing like spam posting or, I don't know, aggressive behavior online, which obviously doesn't exist. So just running that, you can actually, for each comment that is posted on an article, try to define if that's a positive, negative one, insulting one, and then do whatever you want with that. So removing them if they're insulting, for example. So what we're doing there is using the package by Kyrian and just getting all the things from the database, pretty basic. And we're creating what we call a pipeline. So basically feeding that information into the model. And for each review, we're going to send that to the pipeline and get a score. So the way it works is that that model is made for this. You inject text, it gives you a rating out of 100 if it's positive or negative. That's all what the model does. But the good thing is that model is like 2 megabytes. So it's fast to run. You can deploy it anywhere. It's super easy. If we try that, so let me actually just get there. So I'm connecting to my deployed environment on Epson. And now I'm going to do a scoring. So that's just a Symfony command that takes all the reviews for that product queue and then analyzing it. So we've got 108 reviews. It's going to take a bit of time. It's a Nintendo Switch, completely random example. And it's going to go for those 108 reviews and define that, yeah, based on what I know about the text, we've got 79 positive, 29 negative. That went up to 108. And that's 73% positive. So thanks to that, you don't need external system to do those ratings and stuff like this. You can calculate everything directly. And that's great because once again, it was 2 lines in my program, just a package on top. It's super, super simple. By the way, if you want to have fun with that, there is a lot of data sets around Amazon reviews online. So I've imported 28 million reviews to do that. It was quite long, but it's fun. So you can take all that text and define the different ratings. And once again, we can imagine that for a lot of different use cases, moderation, fraud detection, whatever that could be. The second example we're going to go through is actually more image classification. So imagine your user uploading an image. You want to be able to add an alternative text. You want to add tags. You want to see if the image is provocative and you want to delete it. So you're going to need to run that through a model capable of analyzing the image directly. And once again, it's even easier than the first one. Using the Transformers PHP Library, you just, I'm using GD there, but you could use ImageMagick as well. You load the image, and then you send that through the pipeline. Where's my pipeline? Yeah, the pipeline image classification. One thing that is super important with the library is that the pipeline has different tasks like text classification, image classification, that are independent on the model you're using. So you could switch model based on different use cases if you want to. And let's see if it works. Okay, the link is not working. Love it. So I'm just going to upload an image. And basically my app is made to detect if that image is a hot dog or not. So yeah, I know. You may have seen that in a TV show somewhere. And yes, this one is actually a hot dog. So basically what the model gave me is hot dog, and red hot for some reason. If you test something else, like just a regular dog, it's going to say, oh, it's not a hot dog, it's a golden retriever. What's interesting though is that I'm in production there on a really small machine, and uploading the image and getting the results is like nearly instant. It takes like half a second to do the detection. Obviously, if you're doing it with large data set, let's say you upload like, I don't know, 10, 100 megabytes raw images, it's going to take longer. But basically on small JPEGs and stuff like this, it goes super fast. And you're not using a lot of resources. So once again, you can think of implementing that really in your real production application today. It's actually working great. I've lost this slideshow. The LLM generation is a bit more tricky. And you can see how AI can output some really weird images sometimes. LLM generation is a lot more complex because those models needs to be learned on a lot more data and are usually way larger. We mean like, I don't know if you've seen like, for example, Mistral, the open weights model, their best model is like 8 gigs or something like this. And when loaded in memory, it's even more. So we can't really do that on classic servers. For that, you need pure GPU infrastructure and stuff like this. But there's still some possibilities to actually do that. There are a few models that are really small. The FLAN T5 is a good example. I'm going to talk about small ML in a few. But those models can run in like 1 CPU, 2 gigs of RAM. They don't need a lot of memory. They're not super fast. You're not going to output like 100 tokens a second, but they're quite good. So the same way, in our pipeline, we should say, hey, I'm going to give you some text. I want some text back. I'm going to use this model. And then the same way you would use the ChatGPT API, you can actually customize things like the temperature. If you're not familiar with it, the temperature is basically how creative the model can be or just sticking to the rule. And once again, thanks to the transformer and the attention model on it. So, got my other demo. And one of the most impactful questions of those last 20 years, can a taco actually be considered as a sandwich? It's not an easy question. If you get into it, you realize that everything is either soup, sandwich, or, Greg, help me on that one, soup, sandwich, or sushi? Yeah. And based on my model, yes, a taco is a sandwich made of bread. Thanks. Super useful answer. But once again, you're not going to develop a chatbot with this. It's not made for that. But if you need to generate some text, once again, that could be for alternative text for images, description, metadata, whatever that could be, that can actually be used without any issues. And once again, it's pretty fast. I'm running like 2 CPUs, 2 gigs of RAM on that instance. And yeah, it took like maybe 1 or 2 seconds to generate the text. So once again, can be used. All right, now the most important part. How does that actually work? It's not that easy. So we're going to talk about 3 different things. The first one is the FFI extension for PHP. That's not really a pretty new extension, but not being used a lot, that allow you to actually call C libraries directly and execute code directly without any transpiling. And that's great because now, instead of using CGI and those kind of old stuff, you can actually run those libraries independently and way faster. So FFI has helped a lot. And by the way, you could use it for a lot of different things like calling binaries and stuff like this, which is really great. And that's basically, when I was saying that those transformers are architecture dependent, that's basically we use FFI to actually run C code behind this. The second one, and I really hope you're gonna heard a lot more about that initiative in the next few months, years, called, I like to call it ONNX, the Open Neural Network Exchange. So a bit of context there. When you're creating a model, when you're actually training a model, building it, you're using a framework to do it, whether Google TensorFlow, PyTorch, there are a lot of different options. The problem with all that is basically in order to use that model, to do inference on it, to do some calculation, you need to use the same framework. So if one has been created with TensorFlow, but your production machine runs PyTorch, you can't do anything. So the concept behind ONNX was basically to bring all the big industry leaders, Samsung, Apple, stuff like this, to actually develop an open standard to actually convert one framework output, one model, to that format, so that then you can use ONNX to query any model, no matter how they've been created. And that's great because that means now you can find a lot of those models available and you don't need to care, once again, which tools you need to use to actually run it. Here you go. The second part, obviously, is the library I was talking about. So obviously available as package on Composer from Kirian Obikolu. I hope I spelled that right. I really hope he's not in the room right now. That would be really awkward. But that package has a lot of contributors. Is highly maintained. Is fully stable. Really great for anything you want to do with machine learning on your PHP applications. The last part I need to talk about is how do you get those models? So if you want to try a lot of different things, I highly recommend going to Hugging Face, just browsing around. You can test most of the models online as well. And you've got all those different categories like video classification, question answering, table question token, whatever that could be. You'll find something that matches your use case. Maybe you're going to need to try, test, but you'll find something that meets your needs that you can use with that library afterwards. And once again, they have also a category where you can find all the ONNX models. So you're sure they're actually compatible with what you want to do. And then something kind of pretty new, I think it emerged like 6 months ago. There is a new model done by Hugging Face as well called Small LLM. Yeah. Where basically the goal is to produce a model that is able to nearly output like large text like ChatGPT or Claude would do, but bundled in like 500 megs or less, which is great because 500 megs, you can still load that on most machine around there. Even if you've got like a GPU on your own machine, you can actually run it. And you can run that model through Ollama, whatever you want, or that PHP Transformer library as well. And that's just a really simple example. But now you can even run like large language models locally and try to do some stuff with them. The good thing about that is that you control everything. You know what the model does. You control the input, the output. So it's way better. One of the big issue right now, especially because of the FFI implementation, is no support for GPUs. So as you know, GPUs are way better to run models than CPUs. They're faster. They can load everything in their video memory and stuff like this. So if you really want to do serious big computation, like running larger models, you will need at some point some GPUs. But all the example I've shown you before run on basic CPUs. No need to actually go through that step. So we'll see. I think the different libraries will also evolve to be able to support that. That would be great for PHP to be able to actually rely on those different devices to run those models. But right now, yeah, that's unfortunately a bit of limitation. Quick thing I noticed when I actually prepared those demos and that talk, if you're running a Mac, actually macOS has an implementation where if they find some instruction that will better fit their APU or any other processor, they are going to actually reroute that. So that's interesting because just on my M3 Mac, if we take the example of the reviews I was processing, on classic CPUs, where is my terminal? I was processing 14 reviews per second. Not bad, but not awesome. If you have 2 million reviews to analyze, that's going to take a bit of time. On the Mac directly, it's more than 10 times that. Just basically, the M processors have all those APUs capable of handling machine learning and AI related calls. All right. So once again, it's going to be important at one point. If you really make those models part of your architecture, at one point you will need to find GPUs. And for now, unfortunately, you need to use other Python or Node libraries to do that. I really hope it's going to change and we'll be able to leverage that in PHP soon. It's on the roadmap for the package and for the implementation, so I really hope it's going to change the next 6 months. But yeah, right now, if you're using Haskell, stick to the big ones. So what are you doing if you really want to run a larger LLM model in your application? Well, you've got three options, basically. The first one is to use all the API that are available through the different services, OpenAI, Claude, Mistral, whatever you want. And that's just an API call, so nothing complex about this. Once again, the big downside is that you don't control what the service does, how the model is going to respond, even if that's going to be available or not. We've seen those service providers have a lot of uptime issues over the past few months because of usage, so it's not fully reliable yet. You can also deploy your own model through different services like inference endpoints. And then you've got your own model running on a GPU. It's going to be more expensive, but it's yours, so you can use that. Or you can even build your own and deploy those models yourself somewhere on GPUs, but then you're responsible for operating it as well. So right now, it's still a mixed bag. It's not clear what you should if you're running at scale. Some people are even load balancing between different models to first compare the result, but also having failover if something is falling. That was a really packed 27 minutes. I know I've covered a lot of things pretty quickly. Based on all those amazing people around, I'm sure some of you have some questions, right? Yeah, thanks. So we've got the question cube that I can throw somewhere. No question at all? You ready? I'm really bad at throwing stuff. Nearly.
If you want to use Claude AI or ChatGPT with the library Transformers, you can, or it's...
No, all those service providers don't provide the model themselves. They just provide the API on top.
Yeah.
So they already do the inference on top of the model. So no, you have to go through their own service.
Okay, so you do HTTP code to Claude and you get the response back?
Yeah, the library is only useful if you want to run the model yourself somewhere.
Okay.
Okay. Oh, that's good. It's not far away.
You show us how to use these libraries with already present data. Can we study this somehow? I mean, we get some reviews from database and say, this review is positive, this is negative. I mean, to extend knowledge here of these machines here.
So what do you mean, like doing more analysis and putting back the data in your database, or I'm not sure what your question is.
Training the model.
Oh.
Train study models.
Okay. Sure. So you can do two things. You can either say, okay, that model is good, but is not trained enough, so I'm going to retrain it, and that's going to take a long time and money to do it. Or you can also, what we do calling fine-tuned. So passing a lot more parameters to also give the model test examples. So you send it, for example, like 100 reviews that are positive, saying that those ones are positive, 100 negative, and then it's going to help the model actually better define based on those examples. So it's like test cases, basically. So yeah, you can do the fine-tuning if you want.
Thank you.
Are they... So, sorry, I'm just going to take this question. I'm going to repeat it and then I'll move to you.
Are the LLMs actually language specific? Like, are they based on English, German, whatever?
So the gentleman here is asking if the different LLM are based on specific language, as in English, French, and stuff. Most of the models you're going to find online have been trained on English language, obviously, because that's kind of the basic. But most of the models are able to actually analyze a lot more. the result might not be as good, but 80% good. Yeah. So you've seen the biggest model, like for example, Mistral. They're able to handle like 50 languages without any issues. So no, usually you don't really have to worry about that. Especially if you're doing simple tasks like the positive, negative stuff. They have all those keywords already marked, so it's really easy. Sorry, sir. Go ahead.
No problem. So from what I've seen, the library provides different kind of pipelines for whatever you showed, like image processing and large language models and so on. But on the other hand, you said that it basically can use the same model, but for different tasks. Have I understood this correctly?
No, sorry, it was the other way around. One task can use different models. Well, actually, what you're saying is also true, because if you take a text-to-text generation model, it can be used in different things, also analyzing text. So you can do both. Basically, when you're calling the library, you can specify either I'm going to want to use a default or that specific one, so you can switch. So there, a lot of models can work on different tasks, and all the tasks can use different model as well. Yeah.
Okay. And my main question actually was, is the task basically something that is extendable using that library, or is it more or less built hard into the library or whatever?
Yes, it can be extended, except if you want to maintain a really good level of performance, you're going to fall into the Transformers layers. That's where you need like a lot more time to fine tune and change. But basically, if you want to implement like basic rules on top of the task, yeah, it's pretty easy to extend and add new ones.
Okay, thanks.
I think, do we still have time? Thank you, boss. 2 minutes.
How do you find the most fitted model for your use case?
Yeah, that's a really good question. Usually the most popular on Hugging Face are pretty good, but you have to try. And that's where having a lot of tests on your app is actually going to help. Because actually, when I went through those 108 reviews, I found just reading them, the scoring is actually different. The model is not perfectly accurate. So you unfortunately have to test more and fine-tune more. There are a few, let's say 20 to 30 models that are really taking the lead right now. Those ones are pretty popular and getting better every week. A lot of commits and stuff. So, yeah.
How do you test the results of the model, like the assumptions that you make and the assumptions that we?
So, yeah, testing models is tricky. You need a large data set of tests where you actually pre-define, for example, like those 200 reviews were good, those one were negative. Then you run it through the model and you try to check for differences. But it implies having a really large test data set. That's the only way to do it. There are a lot of tooling that is starting to appear to actually compare models between them. So you can run the same instruction set on different models and try to compare the results. One of the issues with model is inconsistencies over time, meaning that your model could work for, let's say the taco is a sandwich example. Your model is going to run well, and then one user is going to add a comma or dot at the end of the sentence, and the result will go bad because the model understood something differently. The question is the same, but the punctuation is different. So that's really tricky. One of my recommendations, if you have like a live application actually outputting AI generated content to your user, monitor it. It can say really stupid things. There is a big case right now in the US where a guy developed an application to help teenagers and basically discuss with them. So an AI chatbot for teenagers. And the AI actually recommended the teen to commit suicide, which he did. So that's kind of extreme. But you don't want to end up in a situation where your model is actually outputting stupid things to your users. So monitoring. Thank you so much, everyone. We have a lot more interesting sessions afterwards. Once again, we're right there in the hall if you want to talk AI, ML, and other stuff. I'll be around. Thank you so much.